This will be a presentation on just what is happening when things rise and set. We use these words to describe what objects in space, the sun, the moon, stars, and planets, appear to do from our viewpoints on the Earth. First, let's consider what is going on with the Earth in space. Here is a cartoon version of a planet that has oceans, continents, and a polar ice cap like Earth. We'll just pretend this is the Earth. The yellow arrows indicate sunlight coming from a star, our sun, that is outside the field of view that we have here. So it's somewhere way off to the left. By the way, I'm not going to try to deal with the complication of the Earth's rotational axis being at a 23-degree tilt. We're just looking at how a spinning planet makes things rise and set. Also, I'm going to be taking the view, or when we see some other pictures here, we'll just pretend somebody is on the Earth's equator, so they're not as far north as we happen to be. Those are complications, but the basic ideas will still be the same. Now let's see the Earth rotate. From the point of view we have way above the polar ice cap, and this is assumed to be the North Polar ice cap if this was Earth, the planet would appear to be rotating in a counterclockwise direction. We stopped the rotation. We can just draw an arrow that indicates the direction of the rotation, and it's opposite the direction that a hand on a clock would be going, and so we call it counterclockwise. Half of the Earth is going to be dark. That's the side of the Earth that is opposite the sun. And the side that's toward the sun is lit up by the sun. I'll often use the term illuminated by the sun. And the side that's away from the sun is not lit up by the sun, so it appears dark. I haven't completely darkened it here, just kind of shaded it out. There we have our rotation going on again. As the Earth rotates, we might also call this spinning on its axis, and the different points of the Earth rotate in and out of the sunlight. When a part of the Earth is facing the sun, that part of the Earth will experience daylight, and when that part of the Earth is facing away from the sun, in the darkened portion, it will be experiencing night. Now let's consider what a person standing on the surface of the Earth experiences. The Earth is so huge compared to the size of a human that we think of the Earth as being flat. We'll see light from the sun coming to us from the sun's point in space. Let's suppose that the person is up at sunrise on a clear day, looking toward the rising sun. They'd be looking toward the east. If they turned around and looked in the direction opposite the rising sun, they would be facing toward the west. The green arrows I've drawn here that look parallel to the surface indicate that person's personal field of view. They cannot see through the Earth, so anything that is below their personal field of view is not going to be visible. So they can't see to the center of the Earth, and they can't see that part of the universe that is below those green arrows. We say that the part of the universe that's above the green arrows is above their horizon, and that part of the universe that is below those green arrows is below their horizon. Now let's consider the fact that the Earth is actually a sphere and see what happens to those horizon lines. Here I've drawn a person as if they were about 300 miles tall. We're just doing that so we can see where they're going to be on the surface of the Earth, but realize, of course, that people aren't this tall. Imagine we could shrink them down to their actual size, but we're still going to draw their horizon lines. So the horizon lines will still point out in straight lines. There's a little bit of atmospheric bending of light, but it's not going to bend those any, or not an appreciable amount. The parts above the horizon lines of the universe are going to be visible, the parts below it are not visible. And it's important to keep in mind that our horizon line is determined by the fact that the Earth we're standing on, which appears flat to us, blocks the field of view of half of the universe at a time. Now let's move our viewpoint even farther out. Here we've drawn a person as if they were about 3,000 miles tall, but they're still going to have the horizon of a person only 6 feet tall or so. Now look what happens as the Earth turns. The horizon lines rotate with the person because they're determined by where we're standing on the Earth. And as the Earth turns, they're going to turn with us. Because the Earth turns toward the east, our east horizon is the leading arrow when we look at this. We can pause it anywhere along here, and we'll know which way is east and which way is west. East is toward our leading horizon line. This person right here would be experiencing noon. The sun is directly overhead. They're about to be experiencing sunset. They'll be going from that part of the Earth which is facing toward the sun. Their part of the Earth is going to start facing away from the sun, and when that happens, you have a sunset. At this time, your western horizon is going to be sweeping past the sun. Over here, they're facing directly away from the sun now because of the rotation of the Earth. This would be midnight. Now their eastern horizon is about to sweep past the sun. They'll be experiencing sunrise. That's how things rise and set when the Earth rotates into a position so that your eastern horizon sweeps past something. That's when it rises. Big ideas so far. As the Earth rotates on its axis, your local horizon rotates with it. The half of the universe above your horizon is visible, potentially. If the sun is up, that makes it really hard to see anything, or if you've got clouds, that may not be the case. And here's the really big idea. As your eastern horizon sweeps past something, that object rises, and as your western horizon sweeps past something, that object sets. Quite a while back, there was a musical group that had something about this in the lines to a song. But the fool on the hill sees the sun going down, and the eyes in his head see the world spinning round. That was by John Lennon and Paul McCartney. The Fool on the Hill is the name of the song. They were in the Beatles, by the way, a long time ago. Okay, we'll just look at a few things here and maybe put some clock numbers on here. This might be where someone on the equator would be at 6 a.m. in the morning. Their eastern horizon is just pointing at the sun. It has just swept past the sun, so they'll experience sunrise. Quarter turn later, now the sun is directly over their head, and that would be noon. By the way, I'm going to be writing numbers here in a 24-hour clock thing, so the numbers in parentheses will be the AM, PM that we're familiar with, and the other ones will be on a 24-hour clock. Another quarter turn. Their western horizon is about to sweep past the sun. That happens at about 6 p.m. for someone on the equator, or 1800 hours. And then yet another quarter turn. Now they're facing directly away from the sun. And that would be 0 hours or 12 a.m. Okay, we'll revisit these ideas when we learn about phases of the moon, but for now just have those things in mind. Things rise and set when your eastern or western horizons sweep past them.